Okay, so different examples of the distributive property. These are algebra uses. We'll do some in the book like that. We'll do some in the book like this. Okay, but I'm also going to teach you how to use it for basic multiplication and multiplication of fractions or mixed numbers. Okay, so let's look at that. So we're using the distributive property. We're breaking things into pieces. Okay, we are going to take the number 9 times 25 right now, okay? Now, some of you can do that problem. You know how to multiply that. I'm showing you how to use the distributive property. How could I write 25 as two different numbers? Think easy. 20 and 5, right? Isn't 25 the same as 20 plus 5? Okay, so let's do that. So 9 times 20 plus 5. Okay. So all I did was break it into two parts. Now I can distribute. You know what makes this nice? I can do 9 times 2 because I know how to do 9 times 2, or I should know how to do 9 times 2. I put the 0 on the end because it's got that 0 there. And then I do 9 times 5 and I add them together. So 9 times 2 is 18 with a 0 is 180. Okay. 9 times 5 is 45. Now I can add these two together, which is 225. Because 4 and 18 is 22, the 5 comes along. Okay, you should be able to do that quickly. Strive for that. Know how to do your addition. If you need to, go ahead and write 180 plus 45. If you need to do it like this, do it like that. Okay. You should, though, as you work with numbers more and more, those should be coming more and more readily available in your mind. Okay. Don't turn to the calculator right away. Try to do them in your head, because the more you do them in the head, the faster they will become. Okay. So that's a way of doing that problem. Let's look at this problem. Okay. 11, that's a whole number, times a mixed number, correct? Everybody look at that? Okay. How else could I write 2 1/4? Can I write it as the sum of something? What does 2 1/4 mean? If I were to measure it, how would I measure it? Let's say it's inches.
2.25 inches.
Do you see that on a measuring tape, 2.25?
You can go.
So where would you go first on the measuring tape?
5. 2.
You'd go out to 2, right? And then how much farther would you go?
Quarter.
A fourth. Okay, our measuring tapes are broke into eighths usually for inches. 2 1/4, right? Okay, so really this is 2 plus 1/4. When we write 2 1/4, it's really 2 whole numbers plus 1/4. Okay, yes.
Can we change the 1/4 to 25?
No, I want you to leave it as fractions. You know why? Because most of the decimals we want to keep exact. We don't want to get decimal numbers. Those are not exact. Fractions are exact. If you're doing some sort of project for your company, they don't want about, they want exact numbers. Okay, they don't want rounded numbers. They want exact numbers, so you need to learn not to use a calculator because those give you approximations. Jonathan. Okay, so this really is 11 times 2 plus 1/4. I could rewrite it that way. Okay. I can now distribute the 11. Do you see how much easier this is than making it a mixed number and getting huge numbers? Okay. I can do 2 times, or 11 times 2. I get 11 times 2, which is 22. I get 11 times 1/4. What is 11 times 1/4? What is 11 times 1/4? Yes.
Would it be 11/4?
It's 11/4 because think about when I multiply, 11 has a 1 underneath it, right? Any number can have a 1 underneath it. Ouch. Okay, so this is 11/4. Now, you do have to do a little bit of changing here. But what is 11/4? How much is that? How many times does 4 go into 11?
2 and 3.
It would be 11/4 because 4 goes in here twice. There's 3 left over, so it's 2 3/4 plus 22. The answer to this problem is 24 3/4. A little bit easier than making this 9/4, 11/99/4, and then having to come up with that. Okay, so it's a little bit easier. Okay, so breaking them apart can be easier, and then we add them together. So we just have to learn to add. Okay, now let's check another one. Let's do this problem. 1/3 times 6 plus 1/4. So it's 6 1/4 times 1/3. Okay, we can distribute it, right? So here we're going to distribute this, and I encourage you at this point to say 1/3 times 6, and you put the 1 under it. So I'm taking 1/3 times 6 plus 1/3 times 1/4. Okay. You multiply straight across, or this is where if you know your multiplication tables, you can cross reduce. You know that 3 goes in here once, 3 goes in here twice, so it makes it much easier. So you get 2/1, which is just 2. You guys following? 2/1, which is 2, plus 1 times 1 is 1, 3 times 4 is 12. My answer to this problem is 2 and 1, 12. Okay? We didn't have to take 6 1/4 and make it into a mixed number because normally how we do this problem is like this. You say, okay, 24, 25, so 25/4 times 1/3 equals 25/12. Then I have to decide how many times it goes in, 2 and 1, 12. Okay? 2 different ways to do the same problem. Do you notice I get the same answer no matter which way I do it? You need to come in. Oh, okay. You need to come in. Sorry.
No,
I'm
it's
trying to
So I went to the other way.
Okay, so that's a way to practice multiplying some of your mixed numbers because you can write them as addition signs. Now, I'm going to show you how this works in multiple number multiplication because some of you guys get very confused. And I'm just going to show you, we can do it either across or we can do it down. Okay? So let's say we're doing this. 37 times 42. How many of you right now could say, I know how I could get that answer? Do you know how to do it? Would you get the right answer? Okay, let's try it. Everybody do 37 times 42 without a calculator right now. Tell me what they got. Don't do it yet. Write it down on your paper.
Wait, don't do it, just write it down.
No, you can do it on your paper. He just had the answer and he wanted to give it to me, so I said, write it down on your paper. Just write it on your paper. Okay, who would like to tell me what they got? Ezekiel, what'd you get?
I got 1,340.
I'm gonna tell you right now, I know that's not correct. Okay, what'd you get?
1,554.
1,554. I'm not sure that might be correct. I haven't done this in my problem. That's what you got? Okay. Okay, that's not what you got. Marcy, what'd you get? Same thing? You're still working on it, okay?
She's almost done.
Okay. Now, I'm gonna show you something that for some people might make this process easier. Okay? I'm gonna show it to you both horizontally and vertically. That means both ways. Okay? So, here is one way. What's nice about this is you really do practice your single digit multiplication. Okay? Let's think about what this is. This is 30 plus 7, right? Is that right? You guys agree that this is 30 and this is 7. This is 40 and this is 2. So what I'm really going to do is I'm going to multiply the 2 times the 7 and I'm going to multiply the 2 times the 30 because that's really what I need to do. So what I get is 2 times 7 and 2 times 30. So I'm distributing that to both things because that's what it is. 2 times 7 and 2 times 30. So what I get is 14, 60. Notice all I have to do is single digit multiplication. Okay. This is really 40, right? It's 40 times 7 and it's 40 times 30. So here's the 2 being multiplied by both the 7 and the 30. Here's the 40 being multiplied by both the 7 and the 30. Okay. Single digit. 4 times 7 is 28 with a 0, 280. Okay. 4 times 3 is 12, 2 zeros. 1, 2, 1, 2. Add them all up. If you don't remember how or make mistakes on doing multiplication where you carry, this is a way you can actually do it. The first step is to take the 2 times the 7. That is 7. Then we're taking 2 times 30. Then we're taking 40 times 7. 40 times 30. Add it up, we get 4, 14, 15, 5, 1,554 is correct. Okay. Do you see how I'm just practicing single digit multiplication there? Okay. What we just did is actually another thing in algebra that we do. Okay. We do what's called double distribution. So let's look at it. We have 30 plus 7. Okay. I'm going to do it the other way. We're going to do 42. 40 plus 2 times 30 plus 7. Okay. The double distribution is this. We have to take the 40 times both of these. I have to multiply it by both things. Right? Isn't that what we did? We took 40 times 30, we took 40 by 7. That's what we did. Okay. Then I have to take the 2 and multiply it by both things. Isn't that what I did? 2 times 30, 2 times 7. Okay. This works. You can actually do this. 4 times 30 is 1200. Plus 40 times 7 is 280. Plus 2 times 30 is 60. Plus 2 times 7 is 14. Add them up. Do you notice it's almost identical to this? It's just backwards. This is 1200 first, 280 next, 60 next, 14. It's just the backwards way of writing that out. Now, I like this. You know why I like this? Because it's already lined up so you can add it very easily. Okay? But in math, if we have a problem like this, where we have unknowns, and this is a little bit beyond you guys right now, but I just want to show you, we can do double distribution. It's called double distribution. Okay? We distribute the x. Okay, let's not do that right now. We distribute the x to both things. We distribute the 4 to both things. So I'm taking the x and distributing it to both of those. I'm taking the 4 and distributing it to both of those. Now, like I said, this is a little above you, but x times x is really x squared, because that's how you write that, an exponent. Okay? Plus x times 3, it's just 3 times x, which is 3x. Because x times 3 is 3 times x, so it's 3x. Now you do the 4 times the x, which is 4x, plus 4 times 3, which is 12. Now you can put together what you can. X squareds can't be added to x's, but x's can be added to x's. So I have 3x and 4x, which is 7x. Jonathan, you know this? We're doing 3x plus 4x. That's, nope, we're adding them. 3 plus 4 is 7x plus 12. That is my answer algebraically to this problem. Okay. Same idea as what we really did up here. I am a huge proponent of teaching students to do this before they do multiplication the other way that we teach them, because then it's like, move over 5 zeros. Why do you move over 5 zeros? This shows you why you move over that many spaces, because you're multiplying by tens. You're actually thinking about what you're actually multiplying by. And so this is a much better way for students to see this. When we get to this, this becomes then easier to understand what we're doing. Okay? We could also do it, a lot of people do it like this, where they're doing it just by this. Okay? X times x is x squared. X times 4 is 4x. 3 times x is 3x. 3 times 4 is 12. X squared plus 7x plus 12. You can write it up vertically just like I could write the other multiplication vertically. Okay. So there's a lot of ways to do this. We also can write, let's just show you another one. Let's do, well, I'm going to do this. This one actually is kind of interesting. Does anybody have an idea of how to do that problem quickly? They could do it in their head. What do you think about it? See if you can think about how you could do that problem in your head. Anybody have any way they would do it in their head? Or are those two numbers too big? Yes,
Times all three digits by 7 and then 4.
we could do that. We could time all three by that. Okay. You know what I see? This is what I see. You see what I see there? 399 is very close to 400. 400 is easy because it's got several zeros. Don't have all those nines there. Okay. -1. Now, I could take 47 and multiply it by 400, or if I wanted to, I could do it like this. I'm going to write it this way this time. 40 plus 7 times 400 minus 1. Okay, we're going to take 400 times 40, right? You guys agree? So that's going to be 16 with 3 zeros. It's very easy to figure out because you just count the zeros and do the single digit operation, okay? Then you're going to have 400 times 7. 7 times 400, that's 28 with 2 zeros. Because 4 and 7 is 28 with 2 zeros. That's a plus sign. Now that -1, right? That means I'm going to subtract the next part. I'm going to subtract 40. And I'm going to subtract 7. So if I wanted to, I could add these and then subtract the 47. So this would be 18,800 minus 47. Well, 47 and 53 make 100. You should know those. Because 53 and 47 make 100. So this is going to be 53. I borrowed one from here to do that. So I get 18753. Did you guys follow that? Kind of. These are the kind of things you should be able to think about as you're doing math. Okay? People that can do math in their head, they do stuff like this. They break it into pieces like this. And they say, oh, I got to subtract 47 at the end because really this is just 1 less than 400. So if I subtract 47 at the end, I know I can get my answer if I multiply it by 400 and subtract 47. Okay? So these are things to kind of think about as you're working through math problems. Okay? Now we're going to practice some of these. I want you to actually do it through the distributive property today. So don't start doing it without distributive property. I'll show you how I want you to do the problems. I'm going to put them on the board, except for the algebra ones. I will put those on the paper. Tomorrow you are going to be measuring things in the room, and then you're going to be finding areas of those rectangles. You know what that is? What is it?
All the way around.
Yeah, no, all the way around is perimeter. Okay,
It's all the way around and then inside too.
it's just the inside.
Length
So,
times width.
yes, the area of a rectangle usually is called A equals L times W, or you may see it this way, where this is the base and this is the height.
Is that for a triangle?
No, that's
Base times.
height divided by 2 is the triangle, yes. This is why, though, if we start calling base and height, we then can make it into all the other formulas that go with it, okay? So you know what kind of problem this is? What is it? It's a multiplication problem, right? So you're really going to be practicing your multiplication. And when you measure tomorrow, you're going to measure exactly. You're going to measure to the nearest 1/8 of an inch. Ms. Sager will have measuring tapes. You're going to measure to the nearest 1/8 of an inch because that's marked on measuring tapes. I want you guys to have practice measuring and then multiplying. Okay, so we're going to do some of those problems today. I'm going to give you some problems where they're both in an 1/8 of an inch. so you can do those. We are first gonna take a break. So once we come back, yes.
You can let them know.
Yeah, take a break. Go ahead.